Great. Hello. Thank you, Dr. Wei Yu, for your presentation. I will continue with the EDFM applications for fracture reservoirs and the data management demonstration. My presentation will focus on two main points. The first one will be related to presenting to you our novel reservoir simulator called URSIM. And the second point will be a demonstration on how to use our advanced EDFM approach through the user interface that we have created. This includes the data scheme and management, a live exhibition of the workflow, and some visualization capabilities. It's my great pleasure to present you and release for the first time our URSIM officially. URSIM is the result of valuable feedback from our clients and partners who claim for a smoother workflow and data transition. SimTech understood that despite EDFM can be a powerful tool, it was kind of limited to third-party commercial simulators, structures, their input formats, and their capabilities, because essentially we did not have access to their source code. So this actually resulted in some complex data transition for new users, especially, that at the end of the day became a little time consuming. In that sense, and in an effort to facilitate EDFM fracture characterization to new users, we have developed new tools and completed the characterization cycle to perform numerical simulation more efficiently and smoothly by introducing URSIM. URSIM is derived from UTCOM-RS, and that means that it's actually the result of more than 20 years of development. Actually, it can be considered a new version of UTCOM-RS that is designed to read Eclipse simulation deck format. That means we did that because essentially most of the reservoir engineers or simulation engineers are familiar with this kind of format. It's standard, and introducing new keywords will just make the process a little more complex. So we facilitate the transition and the learning to use this reservoir simulator. The greatest features of URSIM is that it includes EDFM. Actually, it's a big module on URSIM, so that you can directly transfer the fractures into your reservoir simulator. Another fundamental part is that we will include the new module for handling bugs and cards through free flow modeling in URSIM. More details on this new module that we will develop for URSIM will be explained by Joseph Lanes, but I just wanted to give you a heads up of what is coming for URSIM. So now, please let me show you some field applications that we perform with URSIM. Actually, this is a case I want to present you from Dr. Wei Yu, that he mentioned it from our services for a carbonate reservoir characterization that included, as you can see, 22,000 fractures. I want to stress the importance that EDFM running time was only 7 minutes and URSIM running time was only 20 minutes for 10 years of production. Other field applications include a fracture reservoir simulation that encompassed more than 16,000 fractures and took 20 minutes to process them through EDFM due to its complex gridding, and about 30 minutes to run with URSIM for 10 years of production. The second case on your right is a gas carbonate reservoir that processed about 1,700 fractures in only 2 minutes and completed its URSIM simulation in only 4.15 minutes. These are very good examples of fast, reliable fracture reservoir characterizations thanks to EDFM and URSIM that included not only 2D fractures, but 3D ones, and honor the geological attributes and spatial distributions. So now we want to take the opportunity to show you how the data management for applying EDFM in fracture reservoir characterization is performed. The workflow starts by reading the input the data automatically in our interface called EDGS. It's a brand new our user interface. The data input comprehends the structure grid, the reservoir properties, the initialization parameters, and of course the fractures as DFN in this case. Next, all those data can be processed and corrected through different modules of EDGS to finally run EDFM to model the fractures and link to your reservoir simulator. So EDFM outputs are automatically merged into the reservoir simulators to run the numerical cases. This has been enhanced thanks to the feedback of our users. And now EDGS also can read out the simulation results and generate some very nice and dynamic visualizations of the dynamic characterization of those fracture models. So I'll move into the demo very quickly, but I just want to give you a heads up of what we're going to see. In general, what we did is we processed this sector model that I'm showing you of a single well. It has some complex features in terms of the structure and the corner point grid. We also included some natural fractures that were generated for that specific sector model. And you will see how we transferred all of this geological interpretation into a dynamic characterization of the DFN by our EDFM technology. So please, let me show you our new interface with the demo. So can you see, right, the platform now? And this is the first interface that you will see from our user interface called EDGS. And my point here is that the workflow actually starts by going through the tabs from left to right so that you can process smoothly all the data. I will go in detail to some of the tasks. I will skip some of others because we have different features that for a matter of time, I cannot show you. But in general, the first tab is related to the project setup, where you're gonna save it or open it. The second tab is related to the reservoir information and the grid information. For that, we have included a rescue import plugin that actually facilitates a lot the data transition from a rescue file that you might have, which you just need to click on that. And it's quite simple, quite fast, quite friendly. You just load a rescue file, you can read it, and then you select the properties of your rescue file, the wells that you want to import, and later on you can define the outputs for your reservoir simulator. It could be URSIM, as we showed you, CMG, Eclipse, or Nexus. And you can also output or select which unit you want to output the results. Then you can save it and keep that as a reservoir input. I want to also mention that it's very important that we have developed this rescue import so that now we know that format very well, and that will help us to achieve our goal to generate a Petrel module, since we are familiar now, very familiar with the rescue format. And we have this other module called EDFM input, which helps you to do some data corrections or apply different constraints in terms of the reservoir simulator, the reservoir definition, the wells, the porosity, the permeability, and the initialization parameters. Just in case, otherwise you can just keep moving into the next module, that is the fractures. In here, you can generate your own fractures based on planar fractures for corner points, for Cartesian grids. You can generate DFNs stochastically from natural fractures. Actually, you can draw your own fractures with this module on a map if you have that, or you can read some microseismic events and generate, based on our algorithms, complex fractures from there. In terms of natural fractures, you can also have these modules to import fracture systems from third-party software such as Petrel, Fragment, Fracaflow, Kinetics, or Gopher. In this example, I will show you how to just transform a FAB from Petrel to our EDFM input. So here what you need to do is to just load the source file of the FAB. Here you read it, and as you can see, we will transform about, in this case, 300 fractures just for a matter of time. But the important thing is that we will honor and keep all the geological interpretations that assign different attributes for the fractures like aperture, compressibility, permeability, and honor also the spatial distribution in 3D, not only 2D. So with that, you can also do some data corrections, but at the end of the day, the result will be to have your data transferred to EDFM input, as you can see, with honoring the shapes of that has been created for the DFN. With that, you are ready to run. We move to the next tab called simulation, and here you just click on our EDFM logo, and you can see how fast the 300 fractures will be generated. Now it's taking a little longer because it's reading the mesh that is a complex corner point, but it will be just a matter of seconds that it'll finish transforming that DFN into our EDFM format and generating the model. So as you can see, now it's just reading it. It's gonna be quite fast. And the important thing is with this enhanced workflow, the results of EDFM will be automatically merged into your reservoir simulators. As you can see now, it's done. It finished transforming those fractures quite easily, quite fast. So as I was mentioning, here it already finished. So here you can handle like URSIM, Eclipse, CMG, Nexus, T-Navigator directly from our outputs. So for a matter of time, I already prepared some cases when we run the production data, but I just want to stress also the importance of this plugin, the visualization one. In these modules, you can extract the simulation results to have a better visualization and a dynamic characterization of your fractures. So for that, let me show you quite quick the first case that was in the slides. This is a carbonate reservoir, and you can see now the pressure profile of the simulation through time. And the important thing is that you can see the actual dynamic behavior along the fractures, within each fracture, something that maybe other visualization tools or simulators cannot do. Another very good example that we have is the case that Dr. Wei Yu was mentioning about the wire intrusion. This multi-well, they actually are 5 wells, 4 wells, actually show you how you can evaluate and appraise your models for some field issues like the wire intrusion phenomena. For example, here we can see that this is like a first time step. This is the initial wire saturation, but you can see, but through time, you can see how that you will identify those wire intrusion occurrences in different, close to the wellbores, and especially on each fracture, as you can see now. So this is just a very brief idea and sample of what you can do through our great technologies, EDFM, URSIM, and our interface, so that hopefully you understand the powerful of the technologies we have developed. Really thank you for your time now, and we will be open for your questions.